some good questions set up, I think. Hello, everyone. Welcome back to the Fireside Chat, the Q&A session with me, ABK of Neo4j Developer Relations, and my good friend Emil, the founder and CEO of Neo4j, right?
Guilty as charged.
Yeah. What a fantastic day it's been. Or, for some of us, longer than a day already. Like, what an incredible event, right?
Amazing.
Great keynotes. The first Q&A session we had, I thought was really great. If you guys haven't caught that, you don't need to watch that before watching this one, but some good questions there already. And from looking at the queue we've got set up here, some of this is kind of continued conversation, next steps we're thinking through the process.
I think the biggest problem, at least for me so far, has been at any given point in time, there is at least 2, usually 3 talks that I want to see.
Yeah.
Right. And they're also and then I keep flip-flopping between them just to see how they're doing and what's going on, right? Because there's just a lot of really rich.
You don't want to miss a moment.
No,
there's nuggets being dropped all the time. It's like, oh, that's gold. That's awesome. Yeah.
And what always happens to me at every node is I then keep a record of, I'm going to catch this one later. And I think my conversion rate is like 10% of my list. What I then go back to and actually watch on YouTube is like 10% of them or something like that.
It's like the nightstand reading list, you're going to get through. You get through the top 2 books, maybe, some of them at the bottom, maybe you don't always pop up.
You get through the top 2 books at the same rate as you add 5 more.
Right. So let's hop into this a little bit. This is nice. This is kind of a practical question to some degree. It's from Anonymous, apparently, but in Neo4j, can we scale 1 million data points on Neo4j and 1,000 concurrent users? So this is the classic kind of scaling question.
So lots to unpack in that question. So this is an audience of developers and data scientists, so you will know this to be true, that the actual real answer here is it depends. That is always the case, right? Every situation is specific. Having said that, with 99.9% of probability, if it's 1 million, was it a million? Not a billion,
literally a million, yeah.
With 1 million data points and 1,000 concurrent users, that is a tiny data set relative to the capabilities of Neo4j today. So that almost regardless, you can always run that type of scale. And actually, ABK and I did a demo. Was it at Nodes? It was at Nodes. It was
Graph
Nodes.
Connect. It was Graph Connect.
No, it was Nodes.
Was it Nodes? One of our previous events had a lovely demo.
Event, yeah. Where we did, it's the trillion relationship demo, right? So what this one was keep me honest here, ABK, some version of, we ran a trillion relationship social network graph in a cluster of over 1,000 machines, right? Running obviously in the cloud. And we ran an exceptionally terrorizing, tormenting workload on it. And we did that. We scaled it up from 1 million to 1 billion, up to 1 trillion. We had some step function like that, and ran the same query workload on it, and it completed in constant time. And so that is whatever 1 million to 1 trillion. That feels like 1 million, times bigger size than this particular question. So in summary, yes.
So scale from 1 million to 1 trillion, possible with Neo4j, been done. We've been there. People in production all over the map.
All
on
of that
right?
stuff, but the particulars is always makes a ton of sense, right?
It depends.
The depends is the real answer, but that's a very small data set for us.
So you can start and you can grow, and then this goes back to, I think, this is a branch of the Gen AI, LLM questions we've had before, a bit more practical, I suppose. I want to use open source LLMs with Neo4j. Any tutorial or link or where to get started with this stuff?
Okay, love that question.
Yep.
So we just launched a month ago, something like this. Very recently, we launched the Gen AI Stack, which is a partnership, a collaboration with a number of open source companies, notably Docker, and it launched at DockerCon. So Docker for the containers and kind of the orchestration and componentification of that. Us as the database, Neo4j as the database, providing both vector search and, of course, the property graph model. LangChain as the programming and model orchestration framework, and a technology called Ollama, which is used for running local models on your desktop, like on your local laptop. And so I really encourage anyone to check out that. There is going to be a talk in a couple of hours, actually. I don't remember the exact title, but it's by Oscar Hane, one of our engineers here at Neo4j, and Harrison Chase, the founder of LangChain, who's going to give an introduction to the Gen AI stack. But there's blog posts about it, there's YouTube videos about it. So it's a really great way to get going if you want to build LLM-backed applications. So applications that leverage LLMs, either for the entire application or specific features in that application. If you want to get started really quickly, the Gen AI stack has that out of the box. You just do Docker Compose up, it'll fire up a Neo4j container and a LangChain and all of that pre-integrated. So very cool, easy, convenient to get up and running with.
And there's a growing body of course, forks of that, people doing examples of that, writing about that. And what I love about that stack, when you start to learn about LLMs and of course all the kind of mass media coverage of this stuff, it's Google and OpenAI and all these huge players, the investment dollars to spin up the machines to actually create the model. It's like, okay, impossible to do that yourself. You can't do that on a laptop, but like actually,
turns out you can.
Turns out you can. You can run an LLM on your laptop. You can get all the kind of development time experience with this, and then take it from there. Fantastic. Really looking forward to seeing what people do with that, and that session is going to be awesome with Harrison.
Yeah, with Harrison and Oscar. Yeah.
So then, again, this steers back around actually to product, to Neo4j, and I'm not sure where this is headed exactly. This is kind of like product direction. How's the roadmap for Neo4j Bloom, Neo Dash specifically they're talking about? And is there going to be a merger of these two apps? People always want BI and graphs together. Like this is forward-looking, where are things headed, for Neo4j?
Yeah. So many thoughts there. First of all, just generically speaking, one of the things that has always been an asset of the graph model is its inherent capability to be visualized. There is something innate in every human being, I think, where we tend to look at the world in a very connected way. And I can't tell you how many times that I've been in a situation, I go out and I talk to customers, and they're always techies, right? They're builders, people who build things in software on top of Neo4j, right? So at a big company, they would sit in the IT department, right? And somewhere in there is some kind of a print screen from browser, from Bloom, right? And they say, you know what? When I show this to my manager or to the business unit that I support or whatever it might be, people just loved it, right? That has never happened to me before, they would tell me. That has never happened to me before with any other type of database. And I think that's exactly right. I think there are some domains that are inherently tabular. Maybe payroll, that's my go-to example, like a salary list. Like that probably people think of that as a table. But most domains, domain people, non-geeks, domain people think of it as a series of connected entities.
Yeah.
And when they see that reflected in the graph, they just love that, right? And so that's kind of my first view, that visualization capability. I mean, there's one of 3 tracks here, I think, is the visualization.
A visualization, yeah.
Track, right?
So powerful.
So that's really cool. Now, on the specific thing, I actually don't know the specific concrete roadmap for those 2 tools. But the other big trend, of course, for us is the shift to the cloud, right? And generally speaking, what has been on the self-managed side, a set of isolated tools that we try to design so that they work well together, become an integrated suite in the cloud. So some of you have noticed this when you go onto Aura. I just mentioned browser, and we mentioned Bloom. When you go onto Aura, that's actually in one cohesive experience, where actually most people, if you've never used Neo4j locally, you just used it in Aura, you probably don't think of this as Bloom. You probably don't think of this as browser. You think of this as explore or query, that type of a thing, right? And so I wouldn't be surprised if, I think the question was particular to Bloom and NeoDash, right?
It was, yeah.
I wouldn't be surprised if at some point down the line, those two tools would become much, much tighter integrated in the same unified experience.
Yeah, which will be fantastic because exactly as you're saying, like, it's impossible to use. Sure, you can use them by themselves, but we observe people all the time switching between these tools. There's kind of a workflow that evolves. It's different mindset, exploring the querying, and NeoDash, it kind of fits in like another bucket of that. That makes sense.
Yeah, and the other thing that I see with NeoDash is people's ability to share them. It's like, I have this dashboardy view of my data. Now I can take that and share it with my colleagues, like my non-technical colleagues. It's also very powerful.
Now that experience you were talking about earlier about like sharing with, upstream, like, okay, my boss, what am I working on? The visuals, you can understand the mental model you have gets validated visually. Like, oh yeah, I understand all this. This is my business, I get it. And then plus there's numbers in NeoDash, like, okay, and the numbers going up and to the right, as they should.
Graphs. So easy that even a CEO can understand it.
From one of the sessions, one of the users asked a kind of nice one here. Ritra, if I'm getting your name right, asked, what is the benefit of using vector storage in GraphDB over using VectorDB like ChromaDB or Pinecone? And those vendors, by the way, okay, this is back to the Gen AI, large language model kind of world of things. And VectorDBs are kind of part of that story right now. How does this all fit?
Yeah, we touched on this in our first Q&A from this morning, the more, I guess, APAC and EMEA friendly time zone slot. And I zoomed out and took the really broad perspective on AI and graphs. I'll do that a little bit here. Maybe I'll do the narrower, a little bit faster version of it. Basically, when you think about the world of LLMs, what developers want to do today with LLMs is a bunch of different things, right? You have the GitHub Copilot experience, for example, to help a developer become more productive. They want to use it for internal productivity, writing emails, tons of stuff like that. But really, when it comes down to using LLMs in your applications, it tends to be, hey, I want to give the LLM access to my own data. That tends to be, I would call it, let's say 80% of the use cases or something like that, right? 6 months ago, 9 months ago, if you asked around in the industry, how do I give an LLM access to my own internal data? The answer that would come back would be fine-tuning. And fine-tuning is the process of taking a pre-trained model, a vanilla model out of maybe GPT 3.5 Turbo or GPT-4 or
one of the open source ones.
Cohere, Anthropic, Claude, Llama 2, whatever it might be, right? And then continue training it, but people then call it fine-tuning, right, on my own data. That trend has rapidly shifted now towards an architecture pattern that is called RAG, Retrieval Augmented Generation. And this is a big deal. It's a big deal for, in particular, all the developers out there. Because generally speaking, training a model is a very machine learned, like ML researcher, ML engineer, data science-y skill set, of which we have several on this call. I mean, obviously, right? There's a lot of data scientists use Neo4j. But for all the developers, this RAG architecture, retrieval augmented generation, is just a really simple way of achieving the same thing. And you can think of this very much similar to what you do with ChatGPT. If you want ChatGPT to summarize an email for you, you would copy paste it out of your Gmail into ChatGPT, ask it to summarize, or you would upload a PDF or something like that, right? It's the programming sibling to that, right? Which you would be able to say, you know what? I have my application. I'm going to get data out of my database, core pieces of data, hand that off in the context window to the LLM, for the LLM to then summarize or generate or whatever you want to use the LLM capabilities for. So that sets the stage for vector or graph, which I think was the question. So what vector search then does is that, let's say we're building a chatbot that seems to be the hello world of this universe, right? So someone asks a question, then you take that question in natural language, in English, you generate an embedding from that one and search in the vector database. And then you find the documents that are similar to that, right? So that's what vector search does. Of course, Neo4j now supports vector search. So we can do that, right, already if you have added vector index onto the text properties of the nodes, right? So Pinecone can do that. I think that was the Chroma or Pinecone.
Chroma, they were both mentioned. That's right.
So Chroma, Pinecone, Weaviate, any of the vector databases can do that, right? Neo4j can do that. Now, on top of that, you can imagine for all of us here who are graph experts, right? Use that vector search to find a node, right? But then you can use all the graph power to traverse from there.
Right.
And through that, you get back much richer context. And there's a great example of this. We're running out of time here, but there's a great example of this in the demo application in the Docker Gen AI stack, which shows this on top of Stack Overflow data, where vector search could only find similar questions and then return the one approved answer to that. With vector plus graph, you use vector search to find similar question, but then you traverse from there and you say, you know what? I'm going to find the most highest ranked answers. I'm going to find answers by users who are highly voted, right? Or highly ranked in Stack Overflow. You can imagine, you can pre-populate that graph with PageRank, for example. That's just a different magnitude of power compared to what a simple vector database can do.
Right.
So that is my medium length. I mean, I can talk about this for hours, but that's my medium length kind of point of view on the benefits of using graph plus vector instead of just vector.
Right. So I think that sets it up, the answer, like perfectly. And as you say, like there's much more to dive into here. So if there's follow-up questions to this, we're gonna have one more session.
Yes.
After, I don't know, another 6 hours or whatever the interval is, like, something for us at like 1 a.m. Ask these questions on the Slido if you've got some follow-ups. We're going to try to, from this period until the next, we'll track all of those and queue them up. So please, thanks for joining us today. Enjoy the rest of the sessions, and we'll catch you in a couple of hours.
Awesome. Thanks, ABK.
Cheers.
Bye, everyone.